Hello, today I'm going to tell you a little bit more about the expanding diamonds method that we can use to play the game Decodoku puzzles and to do quantum error correction, of course. This time the difference is we are going to use the ability to colour the numbers with different colours in order to keep track of the groups. So hopefully you've watched the last video and know what expanding diamonds is, and let's now go forth and just do some examples with the colours. So we start with the question mark. What are we going to do with a question mark? Let's give it a nice colour like pink, and we assign it the same group as one of these numbers, let's say this 6, so we make that pink too. Then we go along, we find this 7, that obviously belongs to this 3, this 9 with this 1. These are clearly multiples of 10s in their own right, these pairs, so let's make them blue, and let's make all multiples of 10 blue in future. This 4 doesn't seem to have anything particularly to go with, so let's make it pink. We've got this 1 and a 9, which add up to 10, 5 and a 5, 1 and a 9, 4 and a 6, 4 and a 6. We're finding lots of these obvious pairs here. Another 4 and a 6, 7 and a 3, 9 and a 1, 6 and a 4. This is just me telling you pairs of numbers which add up to a multiple of 10. You've probably seen them before in your maths classes. Now here we've got a 5. Let's make that into the same group as this 2 here. And we'll make them green because we don't really know what's going on with them yet. They don't add up to a multiple of 10, so we're going to have to add some more stuff to that. Here we have an 8 and a 2, and then this 2 is next to the question mark, so let's put those in the same group as well. Now we can go around clearing everything up, getting rid of all of this stuff, and we are just left with the stuff that belongs. So I changed the colour there by accident. We're left with just the stuff that belongs in this corner. So here we've got a 6 and a 4, so this question mark is probably actually empty, and here we've got a 5 and a 2, so this must have a 3 in, and exactly, we were right. And I think we also got all of the pairs exactly as they were here as well. Now let's try another one. Randomly generated. Well, this question mark, let's put it with this 2. This 2 doesn't have anything obvious to go with, so let's just put it with this 4. And this pink group now might add up to a multiple of 10 or might not, so we keep that in mind when we're looking at future numbers. Okay, we've got a 9 and a 1, 7 and a 3, another 9 and a 1, and now we've got this 3, which is not obviously with anything, so let's make it this colour. What's that, some sort of red? Not very good with colours, I have to tell you. And what will we add that to? Well, this 6 has a 4, so maybe we can incorporate that as a little additional version of our method, that we look at what we compare it with and then see if those have any obvious pairs. And this one has nothing obvious, so let's make those the same colour. Now we go along, this 1's already part of that 1-9 pair. We've got here a 2 and an 8, and then this 6 obviously with this 4, this 2 with this 8, 1 with a 9, 8 with a 2, 7, again we're not really sure what to do with those. Let's make those this red colour as well, not because they're part of the same group, but because we're just using this red colour to mean stuff that we don't really know what's going on, and they're not really that close to each other, so we're not going to get confused by doing that. So 6 and a 4, 9 and a 1. Now what does this 1 go with? I have no idea. Let's choose the 4 as just choosing something. We go along again, the 2 obviously with the 8. What does this 4 go with? Well, it might as well go with this weird red group. Let's add these ones to it as well. This 6 here, let's change the colours now because they're starting to get quite big. So this is a green group now. This 6 here, well, it's 1, 2, 3, 4, 5 steps away from this now green group, and 1, 2, 3, 4, 5, 6 steps away from all of the weird stuff going along here. So let's add that to the green group, and then this can just become part of the red. So anyway, 7 and a 3, 4 and a 4, 1 and a 1, that actually all annihilates each other. So we don't have to necessarily, I'm just randomly changing colours here because my clicking is not very good. So this question mark can actually be its own group, which we mean if a number on its own adds up to a multiple of 10, it must be 0 or 10, but we don't have 10s in this game. So now we can start getting rid of these things and adding the things to the question marks, and we have got ourselves, oopsie daisy, a winning formula, I hope. If you wonder how I'm playing this, I'm not using the browser version. For a little bit better screen resolution, I'm using an Android emulator. So there we go, we win. Hooray! Let's keep playing till we lose. I'm going for a hard puzzle now. Question mark with the 8. Okay, 4 with a 6, 4 with a 6, 2 and an 8. I really should come up with something better than just saying these numbers, but once I've stopped saying the numbers I get all confused. What am I going to do? This 4 can go with, I have no idea. This 8, yeah. Good as idea as any. Okay, this 9 with this 4. Oh, that was a bad idea, because we could have paired the 4 with a 6. Oh well. We made our decisions, we made our bed, we have to lie in it now. Let's make these a new group, a grey group. Okay, we come along, we've got this 4 and 8, they add up to 12, so if we could find another 8 somewhere that would be great, but there's no 8s in the neighbourhood, so we might as well add it to this 3. And now we've got this 6. Which of these two groups are we going to add it to? Well, we could add it to the green one. So we know we've got a 6 and a 4, we've got a spare 9. And actually we could notice that these add up to 12, that then comes to 15. So we've got 15 here, and we've got 19 here. So they don't really like each other either. Okay, we have to continue. This one with, I don't know, there's a reason I call this hard mode, isn't it? With that 5, for no apparent reason. Although, if we want to sort of cheat a little bit here, we could notice that also, if we add those two in, we get a 6 and a 6, which makes 12 and an 8, so they're alright. Let's actually do a bit of cleaning up here of the stuff we've already actually done. A few more of those weird stray clicks coming in from no reason. Okay. Now, this 9 goes with, no idea, that 8 maybe? Well, let's not have them our nice colour of things we understand. 5 and a 5. Oh, thank goodness. A 7. Let's not use blue as things that we know about anymore, because it doesn't seem like many things that we know about happen. 7 and a 4. Dear oh dear. Okay. Now we've got this 7 and this 6, which add up to 13. But is there anything to absorb that? No. We've got this 3. Well, okay. It looks like when you use expanding diamonds on hard mode, you are asking for trouble. So that's exactly why you wouldn't use expanding diamonds if you were playing hard mode, or something corresponding to it in a real quantum computer. Pretty much anything, any current method that you tried on hard mode in a real quantum computer would fail, and that's part of the reason why we need your help. We need you to tell us exactly how to look into hard mode and find what are the best methods, because things that we use like expanding diamonds are pretty terrible when it gets to problems that are this hard. Now I just sort of randomly did that. Ah, I lost. Oh well. If you could do better, let me know how. Please.